me start recording this. Okay, so hello everyone, welcome to our lesson for our IGCSE Physics for Form 4 students. Right, so I am Mr. Baljit. So some of you have already joined my lessons before, and I'm very happy that you guys continue to join my lessons. And the ones that are new, also thank you so much for joining my lessons. I hope that with these lessons you will start to understand better that in IGCSE the focus that you need to have for you to sit IGCSE Physics, right? Not the SPM Physics, but the IGCSE Physics. Okay, a few of your friends are still joining, but I think most of you are already here. Right, we will be starting now, and I'm also recording this session so that you can use the recording for our next for your revisions or for your reference later on. All right. So our focus of topic today will be on space physics. So space physics is divided into two portions. So I already gave you the worksheet on both of the portions, which is the Earth and the solar system, and also the universe, the stars and universe. So this is a new topic added to IGCSE Physics. Before this, they do not have this topic, so now they added so that it will be also linked to your SPM. In your SPM Physics, you also will learn something about astrophysics. So this is quite related. Of course, the content is a bit different, but quite related to the same topic. Okay, so without further ado, I will start here. So if all of you can hear me clearly, you are ready, so please send to me a thumbs up. Okay, Reza is fine, good. Iris, alright. Damia, alright, good. Okay, alright. So while I'm explaining to you, if you have any question, please do not hesitate to ask. You can always, if you worry to turn on your mic to ask, you can always ask using the chat box. So you can type your message or type your question in the chat box, and then we can always discuss, right? Because space physics is actually a very, very unique topic where we ourselves are still learning about space. We are still learning about ourselves, right? That's why it's very, if you have doubts about anything, I will try my best to answer, because they are not all the answers that I have also, because the limitations of what I know is also something that if I can tell, I will tell. If I don't know, I'm so sorry. But again, most of it I think should be okay. If you have any question, any doubt, so please do not hesitate to ask. It's only enterprise. Sorry, yeah, just give me a while. Who is this? Okay, so let's start with our topic. So our space physics, as I said, divided into two parts: the Earth, the solar system, and the Sun. And then we go into our general stars and then the universe in our tomorrow's class. So for today's class, we are focusing more onto our solar system. Mainly is about our solar system. Okay, so there is a big difference between a solar system and universe. Okay, our solar system is only about our Earth and the planets. Right, the universe is all about the galaxies, about other stars, about other galaxies. Right, there are so many things in our whole space actually. Good. This is some facts that you need to know about Earth. So our Earth is not actually vertical. Our Earth is a little bit slanted at an angle of. How many questions comes out in P4? Maybe one. Adam Darwish, maybe one, maybe two questions. P4 you only have 10 or 11 questions, so they cannot test you on every single thing in the syllabus. But you still need to know all the syllabus, because they can ask one question related to 3 to 4 different chapters. So it can be one question, 3 chapters inside, or one question, 4 chapters inside. So you still need to know all the questions, all the chapters. Okay, so about our Earth, the fact is it is being tilted at an angle of 23.5 degrees. right? So because of that, we actually get the amount of sun different at every place on Earth. So if the sun is kind of being sent from, let's say, from this side, so the sunlight that comes straight, so these are all the sunlight that comes straight. So we can see that there are some portion of the sunlight that goes a bit far distance. Right? It goes a bit longer distance. So because of that, even though both of these sides are facing daytime, so this is also a daytime, right? And then the behind will be a night time, but still the temperature will be different because the angle that the sunlight is hitting the surface of the Earth is different. Right? It is coming a bit further, so that's why there are some countries, even though they are daytime, but they are cooler. There are some countries it is the same daytime, but they are hotter. So usually the countries which are nearer to the equator, such as Malaysia, Singapore, Sabah, Sarawak, these kind of states, right, and maybe some portions of Philippines, right, they will experience hot throughout the year because we are near to the equator. So our equator is then divided into two portions. Okay, we are divided into two parts, which is the northern hemisphere and we have the southern hemisphere. So all these terminologies you must know, because if they give you these terms, they are not going to tell you the meaning. You have to know the meaning yourself. So it is very important that you just not memorize, also you must know the meaning of each of these terms. Right? And again, because of our Earth is tilted at a 23.5 degrees, so therefore we will actually get different amount of sunlight for different countries. So at the same time also, because of we have half of the Earth is facing the sun, another half is facing the other side, so which is experiencing day and night. So therefore we have 12 hours of day and we have 12 hours of night. Of course, this is theoretically. Sometimes we experience a bit longer daytime, sometimes we experience a bit longer night time. That is all because of our orbit around the sun is different. Okay, so in general, we just assume we get 12 hours day, 12 hours night time. That is what we will usually experience. Okay, and as I said, we experience different amount of sunlight based on different the tilted angle and also different distance from the sun. So usually what we will think about will be the sun will be our center of our orbit. So if you have our sun as the center, our planets or our Earth will be orbiting in an elliptical orbit. So since it is elliptical orbit, therefore sometimes we are a bit nearer to the sun, sometimes we are a bit further from the sun. So because of these two differences of distance, because of that also we experience different temperature, different duration of day and duration of night. So we are not exactly a circle. Okay, this is an elliptical orbit, not a circle orbit. But for mathematical purposes, we assume orbit is circle. Right? Only for mathematical purposes. If it is a real life situation, then orbits are all elliptical. So please remember the name as well. The word is elliptical, but for mathematical calculation, we use circle to calculate. Okay, then come to the orbit. So why does an object can orbit another object? So this is all because of the Newton's law of gravitation. That one you will study in SPM Physics. In IGCSE Physics, you are not required to know about the law of gravitation. Right? The Newton's law of gravitation says that whenever there are two objects with mass, if you have one object mass m1, another object mass m2, there will be a force of attraction between them. It can be a very, very light mass, it can be very, very heavy mass. Only that the force will be very significant if the mass is very, very heavy. So there will be a force of attraction. So since the sun is very, very heavy, and our earth is also heavy but not as heavy as our sun, so therefore there will be a gravity between our earth and the sun. So because the sun is heavier, so our earth will orbit around the sun. So basically what will happen here is, so it's something like this. This is our earth and this is the sun. So our earth will orbit around the sun. Not the sun orbits around the earth. So the sun maybe is also orbiting something, we don't know. We haven't even learned or understand anything much about space yet. But we know that there are a lot of planets orbiting around the sun, because the sun is so heavy that it can pull things towards it. So as I mentioned earlier, orbit is not perfectly circle. Okay, they are not perfectly circle, but they are rather elliptical. So you need to remember this term, elliptical. Okay, and because of that, that's why there are times that we are closer, sometimes we are a bit far. So there is a difference in distance, and therefore there is also a difference in timing of your daytime and nighttime, and also there will be seasons. Some countries will also be experiencing seasons because of this elliptical orbit. So the time that it takes for Earth to orbit around the Sun, to be exact, is 365.25 days. Okay, which is for IGCSE purposes, this number you can just round it off to 365. Right, because of the 0.25 days extra that we have. So that's why you need to times after 4 years. So after 4 years you will get our leap year. I'm not so sure what do they call this in Malay, but it's a leap year. Every 4 years we will get, which is we add one more day in our calendar, which is 29 February of some years. Right, so that additional 1 day you will get from, usually they will add into the calendar. The calendar will be 29th of February. Okay, and also because of moving around the sun, there will be also 4 seasons that you need to remember: summer, autumn, winter and spring. Okay, in Malaysia we do not experience these seasons because we are near the equator, so our sunlight is always about the same, right? We don't really experience much difference in sunlight, and we are tropical country. So about this demographic, geographic ideas you learn in geography, you don't learn in physics, right? But you need the knowledge of geography in physics. Without having the knowledge, also you can have some problem in solving some questions. Okay, so what is important here is you need to remember when do the countries get summer, autumn, winter and spring. Right, so based on the diagram next in our notes, so you can see here. So you need to memorize which countries or which hemisphere will get summer, which hemisphere will get spring, which hemisphere will get winter, which hemisphere will get autumn, based on their estimated duration. This is not an exact time, but more or less around these months. Within these few months, we should get, like currently we are in May. So if you are in May, you are going towards the summer basically, right? We are going towards the June, so which is about the summer. Right, so we are somewhere in June around here. So we will start to experience summer. So therefore now our temperature is also increasing. Right, there are also other countries, usually the northern countries. So if you divide this into half, so the way to understand this is you have to divide your Earth into half. The northern hemisphere and the southern hemisphere. Right, so you look it the upward side and the downward side of it. So the same one, if you go towards December, if you divide, so the northern hemisphere and the southern hemisphere, you can see the difference. Right, so that means June and December, they are a pair to make their the seasons. So when it comes to December, so the countries on the northern hemisphere will start to experience winter. Something like Japan, China, Russia, right, Greenland, the northern part of US. So a bit of knowledge of geography is required for IGCSE Physics. Alright, even though the syllabus don't ask you to remember the countries, but you need to know the northern hemisphere, southern hemisphere. These ideas you learn in geography usually. Okay, when it comes to September, you can divide again to half. So the southern hemisphere is experiencing autumn. Northern hemisphere is a bit further away from the sun. So it's all about the distance nearer and away from the sun. And also because of the angle of our Earth tilt angle. Our Earth tilt angle is 23.5. So because of that, we experience all these difference in temperatures, different in seasons. Okay, so just take a 1 minute check on each one of you. Anyone have any doubts or any question you want to ask? Aries, do you have any question? Arisa Damia, do you have any doubts? Anything that playing in your mind? That it can be anything. Okay, it doesn't mean that must be only related to what I am teaching you, but it can be something that plays in your mind also. Fatin Umaira, do you have any question? How to memorize this easily? What this question? Okay, it is a question in a way. How to memorize this easily? Actually, if you ask me, there is no easy way to memorize this because every people have different abilities, right? Your ability and my ability and your friend ability is all different, right? If you ask me, because I am okay with geography, right? My geography was okay when I learned about geography last time. Now I don't learn geography already, but still I will read about knowledge about countries, knowledge about seasons, I will read. So it's quite difficult for me to say that, oh, you can just be good in geography, you will be good in memorizing this. So it's quite unfair. What I will say here is that you find two things to memorize only from here. The other two will be always opposite. That will be easier to remember. So for me, I remember I remember the June and December. I remember these two. June, northern hemisphere summer. December, northern hemisphere winter. Okay, so from there I will start to build, because this picture is in your mind, right? But we need only 2 or 3 information so that we can recall the full picture. So I will recall using the June and December. Usually that is my way. If you feel that way is okay, you can also use that way. So June, northern hemisphere must be summer. So that's why usually people will go visit European countries during the summer, which is usually around June to August. Like you see, your own life experience or your own life knowledge is also important. You cannot just read the books and assume you will become very good in it. It doesn't work for physics like that. For physics, you must have additional knowledge, which not really physics but can help your physics. That is the important part. Why there is an extra day in every 4 years? Because of the 0.25 Heda. Remember, we have extra 0.25 days. Our Earth will orbit around the Sun. So it takes total of 365 days plus another 0.25 days to move around the Sun. So every 0.25, after 4 years you get 1. So therefore, after 4 years, you have 366 days in your calendar. Again, as I said, this is a leap year. A leap year is a general knowledge. It's not physics. There is nothing about physics here. It's just general knowledge, why we have extra 1 day in calendar. Right? So now you know why we have extra 1 day. But for calculation purposes, okay, in your exam, if you want to calculate using the 365 days, don't use the 0.25, okay, just use 365. That's all you have to use. Maybe I should put it here. For exam, you just use 365 days. Unless the question say, use the leap year, then you have to use 366 days. But until now, IGCSE, since 2023, they never asked about 366 days. It's always about 365 days. Okay. Anyone else have any more question? Or any doubts, anything? Remember, space physics is supposed to have a lot of doubts actually. It's very important that you have your own question, your own doubts, you need to clarify. Iris, any question? Can understand? Natra, any question? Natra clear? Okay. Right, and we carry on. So the seasons we are done. Okay. So next you need to know will be about our moon. Right, this is supposed to be a video on the moon. Actually, you can get this video from YouTube, how they do a simple experiment to prove the idea of the sun, the moon and the earth, which is us. We are looking at the moon. So you can see that every time if you are able to see the moon, if the skies are a bit clear, less clouds, you should be able to see the moon, and you will see different shapes of the moon. Sometimes you see the moon to be a full circle. Right? A moon will be a full circle like this. Everything very bright. Right? We call it bright moon. The name in physics is not called bright moon, but yes, it is the full moon that you see. Okay? Usually it's called a full moon. Right? But sometimes you don't even see any of the moon. So it's basically no moon at all. Right? When there is no moon, so we call this as a new moon. It's not that the moon is not there, only that the moon is not showing you the light. So that's why when you see different portion of the moon, means you need to know the name of that part of the moon. So in this picture you can see that you can only see a half of portion of the moon shining, right? This is the portion that is shining. The other portion of it, this is dark. So if it is shining, that means it is reflecting light from the sun. So the moon doesn't have its own light. The moon will reflect the light from the sun. So it depends on which side of the moon is facing the sun, and then which side of us is looking at the moon. So that is the difference here now. Right? That means different places of the moon and different places of you standing on the earth looking at the moon, it will be showing you different portion of the moon. So you need to memorize this whole arrangement of the moons, which is in our next slide. We call that as phases of moon. Okay, so before we go into the phases of moon, you have to understand one thing, that our moon is orbiting around our earth. So the center of this is our earth, and then our moon is orbiting around the earth. So it takes total of 27.5 days. This is the accurate number, 27.5 days. Okay, but for IGCSE purpose, for exam purpose, we consider this as 1 month, and 1 month is equivalent to 30 days. So if you need to do any formula to calculate, make sure you use 30 days. Right? For calculation purposes, make sure you use 30 days. Do not use 27.5. If they ask you what is the time taken for the moon to orbit around the moon, for the moon to orbit around the earth, then you use 27.5 days. But if they ask you to calculate, then you calculate using 30 days. But it all depends on the question. Okay, always focus on what the question wants you to use. Sometimes they will tell you, use 1 month. So 1 month is 30 days. If they say use 27.5 days, then you use 27.5 days. So it all depends on the question. Okay, and our moon do not have its own light. Moon doesn't produce light. Moon will reflect light. So moon is behaving like a mirror. So the light from the sun will hit the moon. The moon will then reflect to people on earth, so that we can see the moon. So the phases of moon that you have to remember are all these. From the full moon, then you get to the waxing gibbous, first quarter. So the half of the moon is basically, if you see half, I mean that is called a quarter. Okay, the first quarter, then you go to waxing crescent, and then you go to new moon go to waning crescent, then last quarter, waning gibbous, and finally to full moon again. So it will keep on repeating every 27.5 days, so approximately 1 month. This will keep on repeating. So I'll let you take some time to memorize. Again, if you ask me what is the easy way to memorize this, there is no easy way, because different people have different way to memorize things, right? I cannot really comment on this actually. If you ask me, just keep repeating. Keep repeating, it will become something like your memory. It's also an easy way to do is by repeating. So the question about memorizing is actually very interesting, right? Because this topic is very new, and this topic also have a lot of things to memorize. So my advice is, after learning from here, make sure you also read once by yourself. Okay, and also repeat and repeat and repeat. Maybe you can sit in a group and start to have your friends telling stories about all this, right? At least by sharing with your friends, you will still learn something. You can help yourself. No need to memorize so many things. Okay. Okay. Any question on the moon? Anything about the moon that you guys have your own doubts, that you have your own something that you have learned before, or something you have heard before that you want to question here? Ikram, do you have any question? Reza, do you have any question? You don't understand? Use Murni and Enterprise. This is a business. Use Murni Enterprise. Sorry, I cannot call you Enterprise. There is a business name. Use Murni. Wan Ahmad Fahim, do you have any question? Mariam, do you have any doubts? Okay. Yes, you have question, you can always ask. You can always type in the chat box also if you have any doubts. Uze, do you have any question? Thank you for your response. Okay, all right. There is no question, then we carry on. So there are in your notes you can see there are multiple slides that I'm showing you different ways that the sun is being reflected. Okay, so this is all about the sun sending light towards the earth, right? And then we get the reflection, right? The sun send light, and then we get the reflection. So it's all about the reflection. So that's why it is full moon, because we see the full half part of the moon. That's why we call it a full moon, because you see the full circle. It's not that you are looking at the full sphere of the moon. Okay, you are just half of the moon. But for our point of view, it appears to be one full circle. Right? We don't see the sphere, but we see the circle. Okay. So this is our moon surface actually. So we have, the moon is not really smooth. There are a lot of craters actually. You can see here, there are a lot of craters. Right? The moon also have two sides. We are always looking at one side only. So the side of the moon that you see now, maybe tonight, right? Tomorrow night you will also see the same side. Next month you will still see the same side. So basically moon can be divided into two sides, right? The side A and the side B. So we are always looking at one side only, maybe side A only. This is the side that we are always looking at. Right? The other side of the moon we never see before. Right? Therefore there was the rocket being launched by India Space Research Center. Right? They actually sent a rover to the back of the moon. Okay, which is not easy task to do. Okay, astrophysics people will know that is not an easy thing to do, right? But the Indian from India, their NASA in India, basically they managed to send a rover back, okay, to study about material, to study about the gas, to study something, right? Because humans are always curious, so when they are curious, they always try to do research and try to send some machines so that they can get information. Okay, so now we come into, we were talking about orbits and things moving around in an orbit. But if they are moving in an orbit, they're supposed to have their speed. They cannot be staying at one place. So they are moving. So if they are moving, we need to know the speed. We call that as orbital speed. Or we can call the planetary speed, we can call it the moon speed around the earth. Okay, doesn't matter, but the general term is called orbital speed. Right? So orbital speed depends on total distance divided by the total time taken. So since our orbit is elliptical, sorry, we have, yes, Heda? Do you have question? No? Okay. So if question. Okay. No question. Okay. All right. So since we are moving around the sun in total time taken of 365 days, so we call that as period. One period of one revolution is 1 year. So you must know how to convert 1 year into seconds, because seconds is the SI unit. So 1 year is equivalent to 31,536,000 seconds. So you must know how to convert from 1 year to 1 month, from 1 month to 24 hours, 24 hours to 60 minutes, 60 minutes to 60 seconds. Right? So if you keep multiplying them, then you should be able to get 31,536,000 seconds. So that is the period of our orbit. Okay, period of our Earth moving around the sun. And as I said, we assume that the orbit is circle for calculation purposes. For mathematics, we assume it's circle. So since circle, we consider that as circumference. Right? It is a circumference. So the distance travelled will be given by the circumference. And the t will be the time taken for 1 year. So we call it one complete orbit. Time taken for one complete orbit is called a period. So again, this is terms that you must remember. So for all planets, for all satellites, for all moon, doesn't matter, whatever object that is moving in an orbit, you can use this formula. So this formula is fixed for all the objects that are moving in an orbit. 2 pi r over t. So r is supposed to be the radius of the orbit. So radius of the orbit have to be careful, right? Sometimes when they draw the orbit, right, they draw it not circle. Okay, so we can see that sometimes the radius is short, sometimes the radius is long because of the elliptical orbit. So therefore, we consider the r supposed to be an average radius. It's not an exact radius, but it's an average radius. Okay, that's why it's average radius, because of the elliptical shape of the orbit. Okay, let you guys read through first this part of the notes because it's very important to memorize the formula. It's about the speed. So speed is meters per second. Meters per second. Okay. Anyone have any question based on this? Any doubts? Heda, no. Okay, thank you. Mariam, do you have any question? Reza? All clear. Okay. Iman Zaim, do you have any question? He just joined just now. Idrina, any question until now? Iris, do you have any question? Okay. All right. Thank you. Thank you so much for your response. Okay. So there are some questions here that I have given to you in the notes. Okay, maybe you can take a little bit of time to try to answer. I will ask you the answers after this. Maybe 4 questions should take you about 4 minutes, I think. I will give you about 4 minutes to answer, all of you. So I will just randomly call your name to share your answers. So take about 4 minutes to answer this. Okay, so any one of you should have the answers ready for question number 1. Maybe Fatin Umaira, maybe you can share your answers. Again, if you get it wrong, it's not just to point you that you are wrong or something, right? Wrong is because it's okay, we can always correct it. Okay, if you get it right, then it's good. If not, it's always something for you to improve and learn. So don't need to worry that you get it wrong, or I'm so worried I get it wrong. It's okay. I want you to try. That is the important thing. You try first. So Fatin Umara, maybe you can share your answer for question number 1, and then maybe I choose Maisara. Maybe you can share your answer for question number 2, and maybe I choose a boy. Wan Ahmad Fahim, maybe you can share your answer for number 3. Number 4 I will discuss, so I cancel the question number 4. Please share your answers in the chat box. And please don't be shy to share also, right? Remember, anyway, I'm not sitting for the exam, you are sitting for the exam. So if you answer now, you get to know now, is better. Rather than later on you go and sit in the exam and then you don't know how to answer. So better to clarify and get the idea. If anything wrong, get the correct idea now, so that easy for you during the exam. So Iman shared his answer for 8.33 minutes. Okay. Okay, second question. I think I asked Maisara to do this. Maisara, maybe you can help to share your answer for number 2. Or anyone else have the answer, you can also share. Maybe Maisara is having some difficulty, but she's shy to ask. So please students, you guys have to respond, because if not, I don't know how to help you. I'm here to help you. I also need your cooperation to be helped. So if you have doubts, you're not so sure about something, you need to ask. Right? You keeping quiet doesn't mean that you already know or something, right? Somehow we need to communicate so that I can help you if you have any difficulties. 7.74 times 10 power of 11. Question number 3 is 1.3 seconds. Okay, let's see. Question number 2 being shared is 7.74 times 10 power of 11. the distance meters. 43 minutes. So sunlight 43 minutes. 1.3 seconds, the time taken for light to travel from moon to the earth. So basically all these questions, they looks like very complex, but actually they are actually very simple question that require you to use V equals to distance over time. Right? Speed equals to distance over time. Iman Zaim, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 7, 8 times 3, 11, okay. Right, so all these questions are actually just basic of speed equals to distance over time. So why we use speed equals to distance over time? Because the light travel in one direction. Right, one direction. So if it travels in one direction, it's just a basic straight line motion. Right, straight line motion. So therefore we can use that. Okay, so the problem here is that, okay, why I need you to calculate this? So if you notice that this value here is actually very, very big. Right, it's very, very big value, very, very long distance. Correct? Since it is very, very long distance, so usually in astrophysics, we will not use these values most of the times. We will convert this into light years as distance. Right, so in astrophysics, distance is considered as light year. Right, even though you can write in kilometers, you can write in meters, but because the values are too big, therefore they will change it to light year. Okay, and according to the light year, so the meaning is the time, the distance traveled by light in 1 year. That is the meaning of 1 light year. Distance traveled by light in 1 year. So that means if you switch on your light source, right, remember, so the light will travel all the way until the furthest point here, 1 year. So you want to know that what is this distance here. Since now you know the time. Time is 1 year. The speed, you also know the speed of light is 3 times 10 to the power of 8 meters per second. So we want to know the distance. So that is the meaning of light year. Alright, so the distance of 1 light year is equivalent to 9.5 times 10 to the power of 15 meters. Or it can be written in kilometers, 9.5 times 10 to the power of 12 kilometers. So you need to memorize this value because again this is a constant that you have to remember. Just like speed of light is constant, you have to remember. This one also you have to remember. You have to remember the definition, distance traveled by light in 1 year, and also the value in kilometer or in meter. Both are also important for you to memorize. Okay, I'll let you take about 30 seconds to remember the definition of light year and also remember the value for the 1 light year. So this same definition and value I already gave somewhere in the notes. You can see actually in the notes if you have read the notes. If you read my notes, I can guarantee you read and understand, I can guarantee you can answer all IGCSE questions related to this topic. Anything that you need to know for IGCSE Physics, Space Physics, all the informations are already in the notes. The problem will be is how you tackle them as answers in question. That is the worrying part. Okay, so now we will continue from here. So the rising and setting of sun is actually, I gave quite a lot of information here, but for IGCSE purpose, the only important thing is you just need to remember that sun will rise from the east, it will set on the west, right? And then we also have 12 hours of daytime, 12 hours of nighttime. So these are the important keys from this slide here. You don't have to remember everything in this slide, but just remember that we have 12 hours daytime, 12 hours nighttime. The sun rises from the east and the sun sets in the west. So all the other informations are just some additional point that I mentioned related to the seasons earlier. So even the rising of sun in the morning is not exactly at the same place always. If you notice, if you see some shadows, whenever the sun is rising, if you see the shadows are always changing angle. So you can do this research by yourself, that every morning you wake up, you fix one point where you want to see the sun, the shadow of your sun. Right? Then you mark the point for today, then you mark the point for next week, the point for another week, the point for another week. Then you will see that the sun is rising, but it's always rising slightly different angle. Okay, rising and setting of our sun is done. Now let's go to our main focus here usually, the solar system. Okay, remember the solar system is different, the universe is different, right? So our solar system is one part in our universe. It's in basically in one of our galaxy. So our solar system is just one small, very, very small part of our galaxy. Our galaxy have many billions of stars. For our solar system, we only have one star, which is our sun. Okay, our sun is considered as a star. So our solar system, we only have one star, which is our sun. Okay, and around our sun, because our sun is so heavy that it has a very, very strong gravity, so it pulls all the planets to be moving around itself. Right, so we have 8 planets altogether that you have to memorize, from the nearest to the furthest. Okay, so the nearest will be Mercury, Venus, the Earth, and then Mars. So these 4 are the nearest. And then you have the 4 the furthest, right? Jupiter, Saturn, Uranus, Neptune. So these are the planets in our solar system, the main planets. We also have another one which we call it as a dwarf planet. Right, the dwarf planet is our Pluto. So Pluto is not part of our solar system, not part of our planetary system, but it is part of our solar system. So please be clear with the terminologies. Okay, planetary system is only planets. Solar system is planets and also other things. So I'll let you take some time to remember all the planets and the name and their arrangement. So you have to remember from the nearest to the furthest. Sorry. Fatin Umaira, thank you for your, I don't know what is that called, but again, easy for you to remember, you can use that. I use the method of my very excellent mother just served us noodles. You said nuggets, that is fine. If you want to easily remember, so again, as I said, you want to ask me how to remember this, I remember it by names. I don't remember it by these different methods of mother surface noodles. I don't remember in that way. For me, it just come to my mind. Okay, different people have different abilities. Never mind. Okay, so for our solar system, okay, not planetary system. Okay, so the solar system. Our solar system includes also asteroids, include also the dwarf planet, include also natural satellites such as moon for our Earth, and also moon for other planets, and also artificial satellites, and included plus with comets. So comets are also part of our solar system. So you have to remember all these terms. Okay, all the terminologies: natural satellite, artificial satellite, dwarf planets, asteroids. So we have asteroids belt here. So the asteroid belt is between Mars and Jupiter. And then we have comets. So comets are not shown here. I think I showed it in the previous one. Yeah, this is the comet. So comets are a bit different because they come from different places. They don't come from our solar system. So, but they are always around our solar system, moving around the sun. So I'll let you take some time to memorize again all these members of your solar system. What is asteroid belt? It is basically just parts of stones, metals, and maybe inside the stones there are some gases. They are moving around the sun, but they are between the Mars and Jupiter only. Sometimes maybe they will fly out from the orbit. For the asteroids, they may fly out from the orbit, and then they might come to the Earth, and then they will burn. You can see sometimes in the skies. We don't see in Malaysia, right? Sometimes you need very clear skies to see this. So maybe in Middle East countries like US, United States states, some places where the skies are clear, sometimes we can see the asteroids. They suddenly get kicked out from their orbit. Maybe because they are moving around. There are a lot of pieces. Asteroid basically are pieces of stones. Some are small, some are big. So maybe the big one, while moving, they hit the small one come out from the orbit. So when they come out from the orbit, they will be attracted by other gravities, other planet gravities. Maybe the Earth planet gravity, or maybe the Venus gravity. So when they come towards Earth, they basically are moving at a very, very high speed. Sometimes they say it's around 10,000 kilometers per second, or maybe, very, very high speed. So because of the high speed, they enter our atmosphere, they experience a lot of friction, and they start to burn. It's a good question about the asteroid belt. There are pieces of rocks, metals, and some gases in the rocks. Based on the recent studies, there is one asteroid about 10 buildings big. The size is about 10-story building. It's coming towards the Earth. According to the calculations, it will hit the Earth somewhere in November 2027. Rocky and gaseous planets. Rocky planets, basically their main structure, their main material is rocks. Just like our Earth, the main structure is rocks and metals. Then the gaseous planets, their main material is gas. They are compressed gas. So Jupiter, Saturn, Uranus, and Neptune, they are basically gas planets. They have a lot of gas compared to a lot of solids. Okay, Damia? Can you understand? Okay, Ikram, you clear with the explanation just now about asteroid belt? Aries, good question. Why do we have artificial satellite? Currently, you are attending this lesson. Without the artificial satellite, you cannot attend this lesson. When you are out, you need to call your parents. Without artificial satellites, you cannot call your parents. Artificial satellites are for communication purposes. Okay, Aries, you had the idea about artificial satellites? Alright. Okay, remember all your questions are actually important knowledge for you to answer IGCSE Physics. Okay, that's why it's good that you are asking questions. And as I said, if I know, I will answer. If I don't know, I will say I don't know. Because astrophysics is just very big topic. There are not many things that even we, the scientists know. Scientists also don't know impossible, I will know. I'm just a teacher. Right? So, but again, I do reading. So I try to read so that your questions I can answer. Okay, so now you memorize all that already. So these are just the list that you can get. Okay, and also we already started with the understanding of gravity. So we know that all these planets, they are being held strongly by the gravity of our sun. Right? So the gravity of our sun is so strong that it can hold 8 planets moving around it with some other things. Right? But the gravity of our earth can hold our moon and our artificial satellites, and then the gravity of the Mars and Jupiter can also hold the asteroids in between their orbits. So basically, if you consider the Mars and Jupiter, they are in 2 different orbits. So you have Mars and Jupiter. So Jupiter is very big. So in between Jupiter and Mars, there are a lot of rocks, hence the asteroid belt. Right? We call it the asteroid belt. So basically, these asteroids are being held strongly by the gravity of the Mars and also the gravity of the Jupiter. So therefore, they are stable in between the 2 orbits. The gravity is kind of balancing. Right? The gravity of Jupiter, the gravity of Mars, they are kind of balancing the forces acting on the asteroids. But again, sometimes, maybe because of the orbit is elliptical, so the Mars and Jupiter suddenly become too close or too far from each other. So the gravity becomes a bit different. And because of that, maybe one of these asteroids may just fly out. So when it flies out of orbit, it will go into other planets' gravity. So because of that, it will go and hit into other planets. You guys can go and read about more. In 1 year, actually, we have quite a lot of asteroids hitting our Earth. Only that it's not hitting in Malaysia. Right? Therefore, we don't know. In Malaysia, we don't know. Basically, we have zero knowledge of this. But if you go to other countries, right, especially when it comes to the northern hemisphere, when you go to the Antarctica, not Antarctica, I think it's the Arctic or the Antarctic, I'm not so sure which one. Okay, they say that every year we have every month also they have asteroids striking. Okay, satellite. So the gravity of our sun is very strong. So the value we haven't calculated yet. I don't think so any scientists have calculated that. But the value of our gravity, we know that for every 1 kg is 9.8 Newton. Right? For every 1 kg, it is 9.8 Newton. So but this gravitational field or the gravitational field strength, okay, it's very important to know the meaning. The gravitational field strength for our Earth is 9.8 Newton for every kg. That is the important part. 9.8 Newton for every 1 kg mass. That is the meaning of our gravity. We call it gravitational field strength. So it depends on two main characteristics of our planet, which is the radius and also the density. So density also depends on two things, the mass and volume. So that means the greater the mass, gravity also will be greater. Or you can say the greater the volume, means you have less density, that means gravity will be weaker. Right, so for the mass, you have to remember, mass means amount of matter. Amount of matter in an object. So that doesn't mean that if the object is rocky, it is more dense. The object is gaseous, it is less dense. There is no such thing. Because you can have compressed gas, which have more atoms compared to a solid rock. Right, so therefore, there can be some gaseous planet are more dense than rocky planets. Because they have more amount of matter, they have more gas particles compared to the particles of solids. Okay, so because of that, there are some gaseous planets, their gravity is stronger than the gravity of rocky planets. So that is where I mentioned about that idea somewhere around in this table here, you can see. Right, in this table you can see that even though Jupiter is a gaseous planet, right, but the gravity is 26, which is very, very, very high. So on Jupiter, basically we human will die. Right, no need to go also, we just step, we will die straight away. Because we humans are made to learn or adapt to the situation. So currently our human body can only adapt to 9.8 gravity. Even you go to the moon, you can still survive. Gravity is weaker, right? But remember, the change of gravity will also change your blood flow, will change your breathing system, will change your biological system. Right? So currently your biological system, your body only learn how to live on Earth. Because when you are born, you experience gravity 9.8 straight away. So if you change to other planets, you may be able to survive, but maybe survive for some time only. Then usually I think we will die. Because your blood flow is different, your breathing is different, there is no gas, also no oxygen. So there are a lot of different factors can affect your biological system. So the explanation about the gravity just now, you can read through this slide. So I will try to simplify. I'll let you read through first. The gravitational field strength, G. So remember, on Earth, our G is 9.8 Newton for every kg. That is our gravitational field strength. Sometimes they will also use 9.8 meters per second square. This is for acceleration. We call it the gravitational acceleration. So for these two values, 9.8 Newton per kg or 9.8 meters per second square, I believe your teacher would have explained to you when you learn about motion. Right? The motion and free fall. It should be explained in free fall. So please read through this slide first before I tell you about the graph here. So the gravitational field strength, you also need to know about the idea that the strength will start to become weaker as you go away from the planet. Okay. Up to this point, any questions you guys have? Jose, do you have any question? Irdina Aisha, any question until here? Any doubts? Damia, any question? All clear. Okay. Okay, thank you for your response. Gravitational field strength. Okay, you know. Okay. Others are just about gravity, you can read, so the same thing. Okay, what I wanted to explain here is about our gravity graph. Right, so remember that when it comes to our Earth, so our Earth is, we assume it is a circle. Right, our Earth is a circle. And then if you plot based on the graph, if you go onto the Earth's surface, between distance from Earth, from surface, from center usually, and then this will be the gravity value. So our gravity value between, from center of the Earth, this is our Earth, from the center of our Earth to the surface of our Earth is actually constant gravity. But when we start to go away from the surface of the Earth, we are exponentially decreasing. The gravity is exponentially decreasing. So if you consider the radius is r, so we are always decreases exponentially with distance. So if you remove the Earth, so this is how our gravity graph should look like if you remove the Earth from the picture, from the graph. But just to show the clarity, so you have to know that that is the surface. From the surface of the Earth, our gravity will start to become decreasing. So that's why they say that whenever you go far away from Earth, you don't feel any gravity. You feel the weightlessness. Right? That is one thing. The second thing is the gravity will keep the centripetal force there. That's why the moon can turn around our Earth in a circle. So because of the gravity of our Earth, we can maintain the object to be moving in circular path, which is the centripetal force. So gravity provides the centripetal force. So again, this concept of centripetal force, you should have learned in your forces chapter before this, right? When you learn about motion in a circle. So part of the motion in a circle, usually teachers will also explain about the gravity. So I will not elaborate much on this because this is a different topic on circular motion, motion in a circle. So just in case if you suddenly you recall, so this is where we relate the gravity to the centripetal force. So that's why all the satellites, that's why all the planets can move in a circle around the sun or around the Earth, around the planet, because of the centripetal force. So the same concept of the gravity of the sun also is the same, right? If you increase the distance from the sun, okay, the gravity field also will become weaker, right? The orbital speed will decrease. Okay, so why the orbital speed decrease? Because the centripetal force is weaker. Right? Because if you go further away, the centripetal force also will become weaker because the gravitational force become weaker. Right? As the gravity decreases, the speed of the planets also decreases. So that would mean that whenever you have a sun as the middle and you have the elliptical orbit, so the planet here is fast speed. Why? Because it is closer to the sun, gravity is strong. So centripetal force is strong. And then when you go, the thing orbit and then it goes far. So here it's supposed to be slower, because it is further away from the sun. So the gravity is weaker, the centripetal force is also weaker, so it becomes a bit slower. So this fast and slow speed indicates energy transfer. So fast speed is kinetic energy, slow speed is also kinetic energy, but energy, according to the principle of conservation of energy, it must be conserved. So if the kinetic energy from fast becomes slow, it is being converted into some other form of energy. So it's supposed to be GPE. So the energy conversion happening when the orbit, when a planet is moving in an orbit, is between kinetic and GPE. When it is nearer to the sun, kinetic is high, GPE is low. When it is further away, GPE is high, but kinetic will be low. So depending on the distance, right? The distance nearer and the distance further away. So this is what it means from this slide here. Okay, the strength when you become further away decreases. So the centripetal force also will change. Orbital speed also will change. Okay, they will have a smaller orbital speed when the planets are further away from the sun. So when the planets are further away from the sun, they also have longer orbital duration, the orbital period. Right? That's why Mars, Jupiter, Uranus, Neptune, for them to turn around the sun is not 1 year. For Earth is 1 year. For them is maybe our Earth 3 years to 5 years, or maybe 6 years, 7 years. Then only they complete one full circle around the sun. Only our Earth is moving around 365 days. So if you go nearer, such as Mercury is the nearest to the sun. So maybe it takes less than 1 year, maybe a few months only, for one complete circle around the sun. So the longer or the bigger the radius, the longer they take to turn around the sun. Okay, that is the idea of kinetic energy and GPE. So anybody have confusion about when I explain about the kinetic and the GPE? Please, if you have any confusion, please ask. Any confusion, any clarification you need about the centripetal force, and then relate to the fast speed, slow speed, and then relate to the high kinetic energy, low GPE. Any question on this? If you need to ask, you can ask. Okay, no question. Okay, no question. We go straight to the accretion model. Okay, so if any one of you is confused about the word accretion, so please now you can Google the meaning of this. What does it mean by accretion in a simple word? In IGCSE Physics, you have to remember the word accretion model. You have no choice. So please, you can check your dictionary, what does it mean by accretion model or the word accretion. Okay, so it's basically the idea of growth. It can also means that something becoming larger. They call it enlargement of something, right? So basically, how our solar system become our solar system, right? How can we have solar system? Because before this, the space was empty. According to the rule of science, our space do not have anything before this, before the Big Bang. Okay, there was one Big Bang happen, and because of the Big Bang, we start to have things in our space. In our universe, we start to have planets or things around us. So how we become a solar system? So everything starts when we start to have our sun first. Okay, the sun was born first. So once the sun is born, then it slowly start to pull things towards it. Okay, it starts to pull things towards it, and those things over time, maybe 150, 200 million years, maybe 500 million years, or maybe 1 billion years, they start to collect together. They start to grow together. So growing and growing, gravity pulling, growing and growing, gravity pulling, it start to become objects. They start to form planets. They start to form maybe asteroids. Right? So this one takes maybe 500 million years, maybe it will take 1 billion years. It doesn't happen in 1 year or 2 years, right? It takes very, very, very long time to happen. So our solar system is approximately like maybe half a million light years away. So our sun maybe happen about few million years, then our solar system start to build. So this is where they start to call it as accretion model, the growth model of our solar system. So the explanation is given here. So for me, this model is very simple to, it's easy to simplify. Right? Later on, maybe at home, I don't know about the boys, but the girls usually will help their parents to sweep the floor. Right? Just imagine your floor is a lot of dust. There are a lot of things around on the floor. And then as you sweep and sweep and sweep, you give force, right? That is gravity of the sun. Because when you sweep, gravity, you are kind of collecting them all into one place. All your dust, you will collect in one place. Right? You will sweep and sweep and sweep until they go into one side, one whole group. So basically, that is what the solar system experience. Right? The sun is formed first, and then the sun gravity will start to pull all the dust and metals and gases together, right? And then slowly they start to form their own gravity and start to form their own solid objects. So that's how planets are being formed. But again, it takes, like as I said, solar system form was around 4.5 billion years ago, which is basically you are not even here. Your parents not here, your grandparents not here, your great-grandparents not here, nobody was here. Right? After how many billion years, only dinosaurs start to come. Right? And then after how many million years, only dinosaurs all die. And then only slowly start to have animals, other animals start to come. And slowly, maybe according to science, we are formed from monkeys. Right? Then maybe suddenly there is a I don't know, maybe something happened, monkeys start to come to Earth. And over the time, monkeys start to evolve and evolve and evolve, become human. So indirectly saying, humans are also monkeys. Okay, but that is actually how the life start to come on Earth. We are not concerned about the life. Okay, we are concerned about how Earth is formed. Right? Again, that is part of the accretion model. So all the dust that I mentioned that you were sweeping just now on the floor, so all those dust and gases, we call them as nebulas. the hydrogen, dust and gases, we call them as nebula. So please remember this term. You need to memorize that they are called nebula. Okay, there are two types of nebulas that you need to remember. Planetary nebula and I forgot another one. What another nebula? Right, but the main one will be the planetary nebula you have to remember. Stellar nebula. There are two types of nebulas that you have to remember. They call it stellar nebula and planetary nebula. Planetary. Okay, stellar nebula is where the stars are born, stars ingredients. So this is planetary nebula is where the stars die. That will be in our tomorrow session, okay, where we learn about the formation and the death of stars. So all the explanation I simplify using the sweeping the floor method. You can read the slides here, right, with the more clearer physics way of explaining. I want to simplify the idea. That's why I use sweeping the floor, right? Sweeping the floor, gather the dust in one place. So basically, you are creating an accretion model. Okay, and light speed. So earlier I already explained to you what is the meaning of light speed. The speed of light in 1 second is 300 millimeters per second, which is also can be written as 3 times 10 power of 8 meters per second. Okay, and as you have calculated in the example earlier, the light from the sun, it takes about 8 minutes to reach to the earth. So you can just imagine that you are standing on the earth, you are standing on the sun, you switch on a torchlight, but the light will only come to the earth after 8 minutes. So basically the sunlight is not really, the light that you are seeing now is considered as a past light, not the light that you see on at that time. Okay, if you go into your higher level matriculations later on, you will study about light. Light is not a continuous thing, but light is a bundle of energies. So you will learn that in your matriculation later on if you go into higher level physics. So elliptical orbit, as I mentioned just now, okay, we have covered all these, so that's why I'm just giving you more recall and also a bit of more explanations in the slides. So one important information to take here is, remember we have also comets. So the comets, their orbit is a bit different. Right? For comets, the orbit is still elliptical. Right? The problem here is that the angle of the orbit is more than other planets. So as I have drawn here, the green color one, this is how the comet's orbit is. And also important thing to remember here is that the sun is not at the center of the comet's orbit. The sun is at the center of planet's orbit, but not the center of the comet's orbit. So the comet orbit is a bit more slanted, bigger angle, and it's a bit more narrow. It's a bit narrow orbit, not as big as the other planets. So this is very important for you to memorize also, because they have asked a few times in IGCSE questions. So because the planet's orbits are being elliptical, so therefore we are sometimes closer, sometimes away. And because of that also we get different speeds. So here is about the kinetic energy and the GPE I mentioned earlier. So for the energy transformation for our solar system, you only have to remember two types of energies. Because our space is vacuum, so there is no thermal energy, there is no heat. So there will be only kinetic energy and GPE being transferred. So the planets, when they are far away from the sun, they are slower. So slower means kinetic energy is low, but GPE will be high because they are far away. So the distance is very big. Right? Distance is very big. But when the planet comes closer, then the kinetic energy will be high, but the GPE will be low. So the transformation will happen between kinetic and GPE, kinetic and GPE. There is no thermal energy because space is vacuum. Energy transformation. Okay. Other than that, they are nothing. They are just some information that you need to know. Basically, we have actually covered all the important ideas that you need to know for you to understand IGCSE Physics for the first part. Okay, our solar system and the Earth. So just a quick recall. Anything about kinetic energy and GPE? Any one of you have any doubts? Arisa, Adif, I think I didn't see you joining earlier. Do you have any question? Arisa, any question about this? The transfer of energy? So basically you can think about the planet as they move, they become faster, slower, faster, slower. In 1 year, our Earth also will become a bit faster, then will become a bit slower. So because of that, sometimes you can see that we get a bit longer daytime. Right? Sometimes 7 p.m. is already dark. Sometimes 7 p.m. it is still very bright. So we are a bit slower that time. Okay, right. So for the next 20 minutes, we will try to answer. Okay, anybody have any question or any doubts you want to clarify? Just a quick recall that we have covered the first part of our topic here, which is understanding about the planets, solar system, the arrangement, and also about our Earth itself, the period, orbital period. So this is the formula that you must remember. And make sure you also know how to convert 1 year to seconds, or from seconds to 1 year, depending on the question. Orbital speed, 2 pi r over t. The phases of moon, make sure you remember that moon reflects the light from the sun. So different timing, different phases that you will see. So you have to remember from the new moon all the way until you get back a new moon. So one full rotation. Okay, new moon, waxing gibbous, first quarter, waning gibbous. Right? So then you go to the last quarter, then you go to the new moon again. So one full rotation. So a simple experiment, this is how the simple experiment you can explain. If the question asks you, how can you do a simple experiment in the lab to prove the idea of the phase of moon? Okay, you can take a white color ball and then hold it, and then you turn together with it. So this person is basically turning in a circle. And then the person will see different sides of the moon, reflecting the light from the sun. Seasons, and then the orbit, and then why we face different temperatures because of the tilt angle 23.5 and different angle of the sunlight striking the surface of the Earth. Okay, so let's go to some questions. So please take out be ready with the first worksheet that I gave you. I will discuss some questions. Okay, so now we need to apply whatever I explained just now. Okay, whatever you need to memorize earlier, you have to memorize. So now we apply to answering questions. Okay, for the first part, it's not very difficult actually. The tomorrow session will be more difficult. This one is mainly just memorizing, and I would say mostly are general knowledge. Things that you have learned from your younger generation science, right? When you are in primary school also, you learn about some basic ideas about the moon, basic ideas about the planets, right? So now also you are learning about the same thing, a bit more detail, that's all. Okay, so let's see. I will discuss a few questions, then I'll let you guys do also a few questions. So the first question, let's see, which planet in our solar system nearest to the sun? So this one is testing you on idea of you memorizing the distance, okay, and also their nature. So rocky or gaseous. Nature means they are rocky or gaseous. Right? Nearest means the distance. So this one testing you on your memorizing skill, whether you memorize or not the planets. Okay, so the planets. So we know that my very excellent mother, okay, that's just serve us noodles. So you can remember that one. So we know that the nearest supposed to be Mercury, right? M, right? So M supposed to be Mercury. V is Venus, so second, so second planet. And then it must be rocky. So that's why the answer for this will be A, right? Because it starts from Mercury, Venus, Earth, excellent mother, then Mars. Okay, just Jupiter, serve us noodles, Saturn, Uranus, Neptune, right? So the sun is here. So that should be the nearest, and the 4 nearest one should be rocky. So that's how we tackle this question. Means you have to memorize the list. Okay, the list of the planets. Okay, next question. A space station orbits the Earth, distance 7,000 km from the Earth center. So that means you have our Earth, from the center there is a space station. And it is 7,000 kilometers from the center of the Earth. Okay, and then it is making 15 orbits every 24-hour period. So that means it is moving around the Earth in a circle, orbit, right? That is the orbit idea. And it makes orbits, 15 orbits in 24-hour period. So in 1 hour, we don't know how many orbits it makes. So we know that in 24 hours, it makes 15 orbits. So we need to know in 1 hour, because the question wants us to answer in per hour. Speed is per hour. So that's why we need to know in 1 hour, we make how many. So that means it's supposed to be 15 divided by 24. So 0.625 orbits. So 0.625 orbits in 1 hour. So this is the period. Because period is one complete orbit, right? One complete orbit, what is the time taken? So the time taken for one complete orbit is 0.625 orbits in 1 hour. 15 orbits every 24 hours. Sorry for that. So radius is 7,000 kilometers. Period is 0.625. Right? That means we can now divide. So speed will be equals to 2 pi r over t. So 2 times pi times radius, 7,000 kilometers. So I won't change the 2 meter because the question say is kilometer. The answer is also kilometer. So just leave it as kilometer in 1 hour. 24 hours period. In every 24 hours period, 15 orbits. What is the speed of the space station in its orbit? So period is for time taken for one complete oscillation. No, that means I'm doing it wrong. Period is time taken for one complete oscillation, for one complete orbit. 24 hours is for 15 orbits. That means for one orbit, so 24 over 15. So 1.6. So I calculated this one wrongly. So 1 orbit is equal to 1 over 15, so 24 hours divided by 15 orbits, so which is 1.6 hours. So divide by 1.6 hours. So that means we can take 2 times pi divide times 7000 divided by 1.6. So we get 27488.94, which is 27,000 kilometer per hour. Okay, I let you take some time to analyze this question first, because I understand some words, English words especially, right? Because sometimes it's not your everyday language, so it can be a bit challenging. So anything you don't understand for question 2, please let me know. Anybody don't understand how I tackle the question 2? So again, answer you already know because I calculated it. Okay, that is very obvious. But important is how I know that this is how I should calculate. That is the question. If you are calculating, you also need to understand all these terms and words, which I cannot help you, which is your language. Okay, language, you're supposed to have your language teacher helping you. But I can guide you as this question is here, so I can guide you if you have any confusion, so please let me know. So maybe I call up some specific name. Natra, do you have any confusion for this question when it comes to question 2, calculation? Maisara, do you have any problem? Muhammad Muaz, can you understand? Maisara can understand, okay.
Yes, I understand.
Okay, thank you. Sharifah Kirana, nice name. Can understand? Okay. Alright, can understand. Then let's go to the next question. So comets, the third question, blue. Which statement about solar system is correct? So solar system, all planets are rocky, so this is wrong. We have rocky planets, we have gaseous planets. Okay, only Earth has a moon? No. Other planets also have moon. Some planets have more than one moon, so this is also wrong. Pluto is a dwarf planet, this one correct. Okay, there are many stars in the solar system. No, we only have one star, which is our sun. So therefore the answer for this is C. Pluto is part of our planetary system. It's not part of our planetary system, but it is part of our solar system. Okay, number 4. Comets are bodies which orbits the sun in the solar system. What is the shape of the orbit? So shape is always elliptical. Okay, and then the sun just now, position for the orbit of, I mentioned just now, for the comet, the sun is not at the center. Okay, so that's why the answer is D. The sun is only at the center of the orbit for planets, not for comets. Okay, which row of the orbits and the Earth Moon is correct? So approximate time for Earth to orbit around the sun, 1 year. Okay, approximate time for Moon to orbit around the Earth is 1 month, 30 days. Right, so 30 days. So the both correct one is D. So you see, if the knowledge is already in your mind, it's not difficult to answer the questions. As I say, I have repeated many times, so I can automatically remember these things. For you, maybe you need to read through again first. Maybe 1 time, maybe 2 times, maybe 3 times. You have to read and read and read, so that it becomes memory. Right? Reading 1 time in physics cannot work. Reading 2 times in physics cannot work also. Okay, you have to always repeat and repeat and repeat. Then it makes it easier. Okay, let's see a different question, like calculation one like this. Okay, number 10. So the time taken for Earth to orbit the Sun is approximately 365 days. Average radius, so this is our radius. The time is period, we already have. And then to orbit around the Sun, this is the radius. So what is the average orbital speed? So since they ask you orbital speed, so straight away V equals to 2 pi r over T. Right, so 2 pi is constant. Radius, we already have the average radius, 1.5. So they want the answer in meters per second. So have to change the kilometer into meter. Power of 11 meter. Divide by the period, which is 365 days. They want it in seconds. So earlier I already showed you the seconds, right? So it will be 31.5 million, 10 power of 6 seconds. So from here we can calculate the speed. So 2 pi times 1.511 divide 31.5 million. Okay, 31.56. So this gives us about 29,919 meters per second, which can be rounded off to 30,000 meters per second. Right, so basically this is an actual value. Okay, your Earth is moving 30,000 meters. That means every 30 kilometers every second. Currently you are moving. Remember that. Only that you cannot feel because you are too small and the Earth is too big. That's why you cannot feel that the Earth is actually moving at this speed. So this is an actual value that the speed is the Earth is moving. Right? So this is the wonders of universe, because you feel that you are not moving, but actually you are moving. You feel that you are not moving fast, but actually you are moving very, very, very fast. Right? Even your Earth is rotating. Your Earth itself is rotating 460 meters per second, which you don't feel. Right? Your rotation you don't feel because you are too small. Remember that. Okay, we humans are just too small if you compare to the space. So we are nothing. We are just not even the size of a dust. Okay, we are smaller than a piece of dust. But if you are comparing with your friend, then you are not very small. You are quite big. Right? If you compare yourself with the size of a table, then you are not very small. You are very big. But you compare yourself with the size of Earth, we are very, very small. Okay, so you can try out the remaining questions. I will be sharing the answers later on with you. Okay, I will go into the paper 4 questions. So something like this, structured questions. So paper 4 is very difficult usually because if you don't memorize, if you don't know how to write proper sentence, then you may not be able to get marks properly. Right? So especially when it comes to definitions or explanations. Okay, let me explain to you the first question here. Okay, state in order the names of 3 planets closest to the Sun. So they want 3 planets closest to the Sun. And then they also want furthest from the Sun. So that means closest to the Sun, you can, usually we say my very excellent mother, right? So Mercury and then Venus. So this will be the closest. The furthest, my very excellent mother just served us noodles, so I will go with Neptune. Okay, then they say define light year. So as I mentioned just now, in astrophysics, light year means distance. Right? It's not time, it is distance. So it is the distance traveled by light in 1 year. Right? If they ask you what is the value is supposed to be 9.5 times 10 to the power of 15 meters. So in 1 year, the light will travel this distance. Okay, next come to the calculation. So Jupiter is this distance. So that means you have Sun here and you have Jupiter here. The distance is 7.8 times 10 to the power of 11 meters. So the light is this speed, time of light to travel from the Sun. So one direction only. One direction means it is a simple V equals to distance over time. Okay, don't go and use the 2 pi r over t because you don't have radius here, you only have distance. Right? And the light is traveling in one direction. So it is a simple speed equals to distance over time formula. So distance is 7.8 times 10 to the power of 11 meters divided by the time taken, which is t, and then the speed of light is 3 times 10 to the power of 8 meters per second. So from here we can calculate your t. So it is 2,600 seconds. So remember, the mistake done by students, usually they will start to use the method of 2 pi r over t here, right? Because they see some idea of distance, some idea of speed, so they start to use 2 pi r over t to get the speed. Remember, the question is not asking you orbital speed, right? They are asking you just speed. And second indication is it is in one straight line. One straight line only. Okay, it is not as a circle, not moving in a circle. So therefore, be careful, do not use this formula. Mistakes done by students will be using that formula. Okay, let's see the next question. Okay, this one will use that formula because clearly they are telling us about the orbital speed. Right, but again here there will be some things that you have to be careful. The question say the time taken for Mars to orbit the Sun. So again, always remember when it comes to orbit, you have to think that there is Sun in the middle and there is a circle for Mars. So moving in a circle basically. So it takes 690 days to complete this. So the circumference is 290 days. 690 days. Okay, compared to our Earth days. Okay, then they say the orbital radius is the value given. So radius will be this value. So they want to know the average orbital speed. So orbital speed is V equals to 2 pi r over t. So circumference 690 days time. So what we have here is time, the period. So 2 pi times radius, which is 2.28 times 10 to the power of 11 meters. Remember, must be using, sorry, they say kilometers, so we use kilometers. 8 kilometers. Because the question say 1 in kilometers per second, so we maintain in kilometers per second. Period is second. What we have here is days. So we need to convert 690 days into seconds. So 690 days times a day is 24 hours times 1 hour is 60 minutes. 60 minutes is 60 seconds. So this conversion you learn in mathematics, not learn in physics. Right? To convert time from this to this, so you learn in mathematics. So 690 times 24 times 63600. So 2 pi times 2.288 divide. So we get 4 point, something is not right somewhere, wait. Average orbital speed in kilometer per second. 2 pi times 2.28 E8. So I get this as 1.43 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9. kilometers. 690 4 times 3600, 5.96 times 10 to the power of 7, so 1.43 and divide by answer. Okay, so we get approximately 23.99, which is 24 kilometer per second. Okay, and then state the shape of the orbit. So this is always elliptical. Okay, always shape will be elliptical. Okay. Okay. So any problem with this question? Any problem understanding this question? Reza, are you okay with the calculation shown? Ikram, are you okay? Reza, okay. Thank you for your response. Iris, can you understand? Fatin can understand. Thank you. Sharifah Kirana can. Damia, can you understand? Okay. Haidar, understand. Thank you for your response. Okay. So again, if you notice that I always underline or circle the important keywords in the question before we choose what to do. Okay, not straight away start answering the question. So always remember, must make sure that you look through at the keywords first before you answer the questions. Okay, so in our next class, we will be going into a more difficult part of the topic, which will be on the universe. Okay, the universe, and you have a lot of formulas and a lot of understandings you need to memorize, a lot of definitions also. Okay, where it will be covering the idea of our sun, okay, as a star, and mainly will be about the stars. I will focus on the stars. You need to understand the nuclear fusion process happening on the stars, right? And also the name of our galaxies, how the stars are born, formations, and then how the stars will die. Okay, you will study about all this also. And then you also learn about how our universe is expanding, Hubble's constant, the Hubble's law, how they know that universe is expanding. So that a lot of new things you will learn tomorrow, right? So please make sure that you join tomorrow, because it will be very interesting part of space physics that you will be learning. Something that will be very new and very interesting for you to learn. Okay. Alright, so I hope that today's lesson have given you a good idea about basic formation, basic idea of space physics. Okay, tomorrow's lesson will be even more interesting. Okay, so before we end the lesson, do you guys have any question that you would like to ask? Anything else you would like to clarify? If you are clear, you can send a like. If you have doubts, you can question. Okay, so if you have no question, then we can end the session here. I'll see you guys again tomorrow. Can you please answer question 3A? Hold on. Okay, this question 3A, if you realize in my notes earlier, go back to my notes. I already mentioned to you the idea here. Remember about this? Right? So basically, yes, I explained to you. Now come to answering the question is based on your, I would say that based on your language command, and also how you make sure your sentences are easy to understand. Explain the apparent daily motion of the sun across the skies. Right? So basically they are asking you the motion of the sun across the sky. So motion is very simple. The sun rises on the east, sets on the west. Right? So that is the first thing, because they say motion. We cannot see the sun moving, but we can see it's rising and setting. So you can say rises on the east, sets on the west. Right? And then you can also say that because the sun will give you 12 hours of daytime, 12 hours of nighttime. right? So you will see day and night time across the sky. You will see 12 hours of days and 12 hours of nights, but you don't see that, right? You just see 12 hours of daytime. So you see, you need to know what is the main keyword you need to answer in the questions, and this comes only if you practice enough questions. If you don't practice, you just read, you cannot answer the questions usually in IGCSE. You read, you memorize, then you must practice as much as possible, similar to mathematics. In mathematics also, if you don't practice, you cannot answer the question. Physics also the same. You read, you memorize, and then you must answer questions. And you must answer a lot of questions. Right? Especially IGCSE questions, you have to answer the past year questions. There are a lot of past year questions, topicals you can get. Right? So the more question you answer, the more you will realize that they just ask you the same idea but different question. Idea is the same. So maybe in the next paper you will see they ask you something about the sun also, but the question is a bit different. But still about the sun moving, rising on the east, setting on the west. It's the same idea. Okay, does that help? Who was asking me the question just now? Damia? Okay, thank you. So if you are practicing the questions later on, you can also practice and try to answer. If you want to ask me in our tomorrow's class, please ask also. Okay, I can also add on some discussion on these things. You can try to answer yourself also first. Okay, all right. If they are